Power system operation and control. Under that real power frequency control, in that two area system solved problem 1. So a two area power system has two identical areas with the parameters and operating conditions. So the rated capacity of the area is 1500 megawatt, normal operating load is 750 megawatt, nominal frequency is 50 hertz, inertia constant of the area is 5, speed regulation is 3%, damping coefficient is 1%, governor time constant is 0.06, turbine time constant is 0.25 second, and the load increase, that is del PD1, here mentioned as M1, is 30 megawatt, occurs in area 1. So determine, the first one is del F stat and del P12, the tie line power, change in tie line power, and compare this del F stat obtained in single area and comment on the support. So in this problem they asked to determine the change in steady state frequency del F stat and the change in tie line power flow del P12 stat and compare del F stat obtained in single area system. So to calculate del F stat, you can use this formula, del F stat equal to minus del PD2 plus A12 del PD1 divided by beta 2 plus A12 beta 1, and the change in tie line power flow between area 1 and 2 del P12 is equal to beta 1 del PD2 minus beta 2 del PD1 divided by beta 2 plus A12 beta 1, where this beta is equal to B plus 1 by R. Solution. So here in the question it is mentioned that is two identical areas. So first we find the rate of change of load with respect to frequency. So B is equal to B1, that is equal to B2, since these two areas are identical, that is equal to dou PD by dou F, and 1% change in load correspond to 1% change in frequency. So 1 divided by 100 into 750 divided by 1 divided by 100 into 50, that gives you 15 megawatt per hertz. So in terms of per unit, so actual value divided by the base value, so base PR is 1500, so 15 by 1500, that gives you 0.01 per unit megawatt per hertz. And the rated power is PR1 is equal to 1500 megawatt and PR2 is 1500 megawatt. So the rated capacity is given as 1500 and both the areas are identical, so 1500 for both the cases. The power ratio PR1 divided by PR2 is equal to 1, so 1500 divided by 1500, that is denoted as A12, and the speed regulation is given as 3% in the problem. So R1 is equal to R2, that is equal to R, that is 3% of 50 hertz. So here the speed is directly related with the frequency, so 3 by 100, 3% into 50 divided by 1500, so that gives you 0.001 hertz per megawatt. So in the unit hertz per megawatt we are obtaining, that's why we are dividing it with 1500, and in terms of per unit we have to multiply the answer with 1500, so you'll be getting 0.001 into 1500 equal to 1.5 hertz per unit megawatt. And a load increase M1 equal to 30 megawatt occurs in area 1. In area 1 the load increased, that means del PD1 is 30 megawatt. So convert that in terms of per unit, so 30 divided by 1500, the rated power, the base power, that will be equal to 0.02 per unit megawatt. Now change in steady state frequency, that is del F stat. So this is what asked in the problem. So the formula for that is minus del PD2 plus A12 del PD1 divided by beta 2 plus A12 beta 1. And for two identical areas, beta 1 is equal to beta 2 equal to beta, R1 equal to R2 equal to R, B1 equal to B2 equal to B, and A12 is equal to 1. So now substituting this here, A12 is 1 and beta 2 is equal to beta 1 is equal to beta, so it becomes 2 beta. The formula is reduced like this, and we know that this del PD2 is equal to 0. There is no change in power in the second area, there is change in power only in first area. So M2 is equal to 0, so eliminating this term, the formula is further reduced, del PD1 divided by 2 beta. Del PD1 is nothing but M1. And this beta is equal to B plus 1 by R. The formula for beta is B plus 1 by R. So B we know it is 0.01, we calculated in the first step, plus 1 by R. R value is 1.5, the second step we calculated. Substituting, you will be getting beta is equal to 0.6766 per unit megawatt per hertz. So now substituting this beta value and this del PD1 value in the formula. So del PD1 is equal to 30 divided by 1500. So you will be getting minus 0.0147 hertz. This is del F stat. And next one is change in tie line power. So del P12 stat. The formula for that is minus beta 2 M1 divided by 2 beta. So as you know, beta is equal to beta 1 is equal to beta 2. So you can cancel this betas. So the formula is further reduced into minus M1 by 2. M1 is nothing but del PD1. So del PD1 is 0.02 per unit megawatt. So divided by 2, that gives you 0.01 per unit megawatt. That is minus 0.01 per unit megawatt. And in terms of megawatt, multiply it with 1500, the power rating. So that gives you minus 15 megawatt. This is the change in tie line power. So now from this two answers, we can conclude that the value of del P12 stat, the change in tie line power equal to minus 15 megawatt that we received from area 2 is 50% of load change in area 1, that is del PD1. So del PD1 we know it is 30 megawatt, which is given in the problem, but the change in tie line power is minus 15 megawatt, which is half of the load change in area 1. So del F stat equal to minus 0.0147 hertz is only half that of the value of minus 0.0294 hertz, which obtained in the single area system. If you calculate del F stat for single area system, you will be getting minus 0.0294. But here for two area system, the value is 0.0147, which is half or 50% of the value obtained in the single area system. This is due to the support of energy received from the spinning reserve in area 2. So this is the conclusion of this problem.